Well, hello Internet, and welcome to part 2 of my C video tutorial. Today we're going to talk about relational operators, logical operators, if, else, else, if, conditional operators, bits, bytes, looping, and a whole bunch of other things. If you missed part 1 of the C video tutorial, I provide a link to it in the upper right hand corner, and all of the code used here, along with a ton of comments that would be easy to translate, is available in the description. So I have a lot to do, so let's get into it. Okay, I'm using the same setup I used in the first part. I just have a basic text editor, text wrangler if you're on a Mac, or Notepad++ if you're on a PC, or whatever other text editor. And then over here on the right side of the screen I have a terminal or command line if you are using Windows. So I'm just going to start here, and we are going to need the standard I/O library just like before, so we can use printf and a whole bunch of other different things. And then I'm going to define main, of course, because that's where all the action occurs. Now I'm holding a whole bunch of different things back here, and I'm going to explain them as time goes on. Like, for example, in the last part of the tutorial, talked about the size of different data types. This time I'm going to actually show exactly how to find the size of data types. That was actually brought up in the comments. Another thing I want to bring up is if you want to compile one of your programs and the program name .c is set up like that, and you want to actually define what the executable's name would be, instead of using a out, you would just put a dash and then o and then program name, exactly like that. Then what you'd be able to do from that point on is execute using ./program name instead of ./a.out. Just something to think about, and in this tutorial we're going to be using this right here. And I actually have the 2011 version of the C compiler in this, and I'm actually going to do a couple other different things compile wise so that we will be able to take advantage of the changes that have occurred in C instead of using the old version. Now the very first thing I want to talk about is how we can compare different variables. So let's just say we have variable 1 and variable 2. Well, we can use things called relational operators to compare these guys. And of course we have greater than, we have less than, we have equals to, and then we have greater than or equal to, and we also have less than or equal to, and then finally we have not equal to. And throughout this tutorial I'm going to show you a bunch of different ways to work with these. And with these relational operators, anytime you perform this type of operation, you're either going to get 1 if the evaluation is true, or 0 if it is false. And those are actually saved as ints for now. Later on I'll get into booleans. There actually is a boolean data type, but we have to bring in a library for that. And the very first thing we're going to do is put a little bit of a space inside of here, and we're going to start defining some variables that we'll be able to use. So I'm going to have num2 is equal to 2, and then we are going to explore a relational operator right here. So if we just go printf and say is 1 greater than 2, come in here and do this, throw in some new lines, and then we can go num1 and do the relational operator or the condition right here. Then remember, we're going to want to compile this in our new way. So I'm going to go c tutorial2.c, right like that, c tutorial2.c dash, and then an O, not a 0, an O, a lowercase o. And then let's say I want to call it C tutorial 2. And I'm just going to cut this out of here, bounce over to the terminal, paste it in there, and there we go. And then to execute this guy, now I'm just going to go C tutorial 2. And there that is. And there you can see that it evaluates to 0, just like I said before. Now, of course, we're going to get into more complicated things than that. And the very first thing I'm going to do is talk about the if statement. Now, if is going to be used anytime you want to compare values or perform different actions depending on different comparisons that you want to make. So let's say I want to check here if number 1 is greater than number 2, and if it is, I want to put that out on the screen exactly like that. However, what would we do if it isn't? Because of course number 1 could be less than number 2, but it also could be equal to it. Well, you're going to be able to check multiple different conditions using else if in this situation. So we're going to say else if number 1 is less than number 2, and then we're going to be able to perform or print out a different answer to our screen like that. However, There's only one other opportunity or thing that's going to be available to us, and that is going to be that they are equal to each other. And just to keep this simple and all here on the same page, well, actually, let's just scroll up. And then finally, we're going to have equals to, or equal to. Bounce over here and execute. And you can see that 1 is less than 2 is what actually was printed out on the screen. Now, it's very important to remember if there was a situation in which 2 of these conditions were actually true, only the very first condition that is true and the code that says follows it would actually be used. So for example, if number 1 is equal to number 2, like this, well, in this situation, let's say that we came here and we said number 1 is greater than or equal to, well then we are never going to get down to this point. Once a condition is true, the code that is between the curly brackets is going to be executed, and then every other if statement that follows is going to be ignored. So that's very important to remember. And we'll just get rid of that. And that brings us to logical operators. Now, a logical operator is used anytime you want to combine multiple relational operators. And there's a couple of them, and we're actually just going to get rid of this. You're going to have and, or, which is going to be those 2 pipes that are on the far right corner of your keyboard. And then finally, you're going to have not. And or are quite simple. Not pretty much what it's going to do. Remember, we're going to, in any situation where we're performing a relational operator or we're checking a condition, we're either going to get a 0 or a 1. Well, if you put not and then 0, that is going to return a 1. And if you have a situation in which you have not and then 1, that is going to give you a value of 0. So not pretty much just takes whatever the result is and turns it into the opposite. So let's say we have customer age is equal to 38. And let's say that we have a swanky club and we want to check that everybody that goes to our club is either over the age of 21, and we want to check that the customer age is less than 35. And if that age is indeed true, we're going to say that those people are going to be welcome in our club. And yes, indeed, you can ignore the curly brackets if you're going to just put one line or just have one line of code that would be printed in that situation. You can also go else, and again on one line without curly brackets, put in that condition. And the only way this is going to be evaluated to true is if customer age is greater than 21 and customer age is less than 35. As you see right here, they are not welcome prints out on the screen. And to give you an example of how not works, let's go not turns a true into false, or vice versa. And you're going to see if you put not and 1 and execute it, of course, 0 shows up. So just an example of how not works. Let's look at a whole bunch of other examples. Let's say, for example, we want to check if an employee named Bob deserves a raise. Now, the conditions we're going to set here, let's actually just show those conditions so we can look at how the if works inside of C. Bob is going to qualify for a raise if he missed less than 10 days work and has over 30,000 in sales or signed up more than 30 new customers. And let's just put this on the next line. So there we go. This condition has to be met because it is an and one or the other of these conditions need to be met for it to be true. So how are we going to evaluate that? Well, first we need to get some information about Bob. Bob missed days is going to be equal to 8. Bob total sales is going to be equal to 24,000. Remember, don't put a comma in there. And Bob new customers is going to be equal to 32. Well, you can see immediately that Bob's going to get a raise. But we need to check this, and how we're going to check it is we're going to say if Bob missed days is less than 10, and, see, just exactly how we would say it, and Bob total sales is greater than 30,000, or Bob new customers is greater than 30. That is going to be the situation in which Bob is going to get himself a raise. And there we go. We got it all on the screen here at once. Then what we're going to say, if that's true, printf, Bob gets a raise. Else, Bob doesn't. Bounce over here, execute. Bob gets a raise. So there you go. Another example. Another thing that's kind of cool, we can come in here, get rid of all this, because I want to talk about a shortcut way of performing a comparison in which you know that you're either going to get one result or another result. So I'm going to say customer age is equal to 38. Then what we're going to do, and ignore this star for now, I'm going to get into this as the tutorial continues. What we're going to do here is create legal age, and we're going to say customer age. We're going to put a conditional. This is called the conditional operator, and the way it works is you say this is going to be my condition, and if that condition is true in this situation, I'm going to return true and store it in this character array called legal age. If this condition here, customer age, is actually less than 21 instead of greater than, we're going to return false, and this is the conditional operator. It's very, very useful. Then what we can do, go like that, and remember this is a character array, so this is going to be considered a string. Once again, don't worry about it. I can't cover everything in one tutorial. And we file save that and execute. There you can see, is the customer of legal age true? See? Pops back. So that's an example of the conditional operator. It's quite useful, actually. Another thing we can do with it, let's say we define number of products, and let's say we make that equal to 10. Well, I can come in here and do a printf in a really neat way using a conditional operator and say something like I bought, throw in a string, products, like that, and then put a conditional operator that says num of products. If it's greater than 1, what we're going to return as a string is going to be many. Otherwise, we're going to return 1. And as you can see, I bought many products gets thrown in there. So that's kind of useful. And we're going to get more into different things that we're going to be able to do here. It's a whole never-ending supply of different things we're going to be able to do with C. Now I'd like to talk about something that I actually planned in the last tutorial, but one of you guys actually commented on it. And that is specifically how much space do data types actually take up? How big can an integer really be, or a character really be? Well, there's actually a way to find that out. In the past, what I was referring to was the past, the minimum size for an integer, and not the maximum, or necessarily your size or your maximum size for an integer depending upon your computer. There's actually a way to figure that out. So we're going to go and do this. We're going to say a character takes up bytes. And I'm going to get in here in a couple seconds exactly what a byte is and what a bit is. To find out, you can actually throw a variable name inside of here, but you can also just throw character inside of here, and that's what we're going to do just to keep everything nice and simple. And we're going to find out just how big all of these different guys can actually be. So we're going to say a character takes up, an int takes up, and then we're going to throw an int inside of here. A long int takes up, and then we're going to type in long int. Then we're going to type in float, and then we're going to type in double, and float, and double. I'll save, bounce over here, and there you can see a character is going to take up 1 byte, an integer is going to take up 4 bytes, a long is going to take up 8 bytes, a float's going to take up 4 bytes, and a double is going to take up 8 bytes. But what exactly is a bit, and what exactly is a byte? Well, a bit is actually short for binary digit, and a bit can either be a 1 or a 0. That's it. A byte is generally considered to be 8 bits. And I have a little handy presentation, and I'm going to show you exactly what I'm talking about. So let's say we have 1 byte, or 8, 1, 2, 3, 4, 5, 6, 7, 8 bits. Well, if that byte only has zeros in it, that is going to be equal to the number 0. However, if it has a 1 in this placeholder, that's going to be equal to 1. A 1 here and a 0 here is going to equal a 2. 2 1s is going to equal a 3. And then a 1, 0, 0 is going to be equal to 4 as a decimal versus a binary number. So what exactly does that mean? Well, let's just look at it as a smaller number of bits, being 3. Well, everything is structured as a binary number in that this can either produce a 0 or a 1. And then the possible numbers that it's going to produce from that point forward are actually going to double as we increase the number of bits. Now stick with me here, this is going to totally make sense. So for example, if we have a binary number, which is 1, 0, 0, we have to take this situation in which we have a 1, count over knowing that this represents a maximum value of 1, 2, and 4, and that tells us that the binary number of 1, 0, 0 is actually using our normal way of counting, representative of the number 4. Let's look at another example. In this situation, as you can see, everything doubles: 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32. So how exactly are we going to calculate this number? Very easy. We're just going to take 32, 16, 8, 4, 2, and 1, add them all together, and get 63. That is how we translate binary numbers into our regular old way of counting. So in reference to exactly how characters work, why exactly is a character 8 bits or 1 byte inside of memory in our computer? Well, here we have all zeros and we have a byte or 8 bits. Like I said before, these numbers are going to continue to double for these 8 bits. And what that's going to allow us to do, if we add up all of these, is represent up to 256 possible characters if we include 0. This actually adds up to 255, but that's not counting 0, of course, as a possible number. So what exactly does that mean to us for integers? Well, I didn't list them all out here. There's actually going to be twice as many different bits available for all of the possible integers that can be stored. But then, if you add up all 32 boxes that can hold a large integer, that would mean that we would have the capability of holding 4,294,967,295. But that doesn't take into effect the fact that we're going to be able to store both positive and negative integers. And if we take a look at that, that shows us that actually on this computer, and more than likely on your computer, you're going to have a maximum value that you can store inside of an integer of 2,147,000,000 blah 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 blah, and a minimum of negative 2,000,000,000 blah 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 blah. So let's take a look at that in the code. So here we are back again, and this time what I'm going to do is I'm going to say int big int, just going to call it that, and I'm going to go 2,1,4,7,4,8,3,6,4,8, and then we can do something like printf I'm bigger than you may have heard, like that. And there you can see I'm bigger than you may have heard. However, look at this, negative 2 billion. Why is that? Well, you may not remember, because why would you remember? Actually, the maximum value you can have for an integer ends with 7 and not 8. And that just gives you an example of what happens if you try to input a number that's bigger than the integer can hold. It starts going backwards into negative numbers. However, if we change this to 7, file save, and execute, now you can see the maximum number that our integer can actually hold. So that's kind of cool. I thought I'd get into that a little bit. And yes, sometimes in these tutorials, I actually put information in that isn't necessarily always true, just so that I can make things interesting later on. And there we go. Now let's say we wanted to actually automate this whole process of calculating the maximum value based off of the number of bits that we have. Number how big is equal to 0. And what I'm going to do is I'm going to say printf how many bits. Then I'm going to do a scanf and ask that person exactly how big is the number of bits. And then we're going to think here for a second about exactly how we are going to write this code. Well, we know that if they have 0 bits, well then the answer is going to be print what is given. Same thing is going to be true if they have 1. That's also going to be print what is given. However, what happens if they type in 2? They have 2 bits, and you want to return the biggest number that they can possibly create. Well, that's going to be created by going 1 plus 2, and that is going to give you 3. Or in the binary world, that's going to be equal to 1, 1. Then, if we go 3 bits, how big of a number can we make? Well, that's actually going to be 3, and that 3 comes from here, the result of that. Then to that, what are we going to be adding? Well, remember, this starts off at 1, then it doubles to 2, then it becomes 4. And that is going to give us a maximum value of 7, or in the binary world, 1, 1, 1. And then if they would type in 4, that is going to, what are we going to do? We take this 7 from right down there, type that in there, da 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 da. 4 becomes an 8, and that gives us a maximum value of 15, or in the binary world, 1, 1, 1, 1. And I think we have enough information we can start putting together our little algorithm here to solve this. So what are we going to want to do? Well, we basically have 3 guys at play here. we're going to have our final result. We're going to have this guy, which is going to be whatever this previously was. So 1 goes to 1, 3 goes to 3, 7 goes to 7. And we're also going to want a multiplier that starts off at 1, becomes 2, and then goes to 4, and then goes to 8. So just to keep this nice and simple, let's say we need 3 different variables to be able to perform this calculation. And I'm just going to say my incrementer, and the incrementer is going to start off with a value of 1. Then I'm going to have my multiplier, which is going to be this guy right here. This is going to multiply, and that also is going to start off at a value of 1. And then I'm going to have final value, which is going to represent these numbers right here, so that I'll be able to spit that out on the screen whenever I get to the point where it is finalized. And all of those are going to start off with a value of 1 to start them off. So then what I'm going to do is I'm going to say while my incrementer is less than my largest number that they can possibly enter in here, well, I want to perform some calculations. My multiplier immediately is going to start off, and it is going to multiply whatever times itself, which is going to have a value of 1 the first time, and then go to 2, which is right here. And actually, to keep this simple, after this, what I'm going to do, because of course if this is equal to 1 and this starts off as 1, nothing inside the while loop is ever going to execute. And I'm kind of playing around here a little bit just so that I can show you more examples of if statements and while loops and a whole bunch of other different things. So I'm going to say if number how big is equal to 0, or number how big is equal to 1, like that. I'm going to say printf top value based off the number of bits is going to be whatever they entered. So number how big. Else, what I'm going to do is go in here like that, and top value is going to be equal to, in this situation, whatever the final value was calculated up here inside of this while loop, which we haven't gotten to yet. So another example of that. And if I didn't mention it, which I don't think I did, the while loop, what it's going to do for us here is it is going to continue to loop and execute this code over and over and over again while this condition is true. Whenever that condition ceases to be true, it is then going to stop executing. So what we're going to do that is very important with your while loop is you are going to have an incrementer, and you're going to want that created outside of the while loop. Very, very important. And aside from that, it's pretty much logical. So alright, so let's continue making this little guy here. We're then going to say final value is going to be equal to final value plus whatever my multiplier is, which is going to start off as 2, as we see there. And that's basically what I'm doing. The final value, 3, is going to be equal to whatever the previous final value was, which was 1, plus the multiplier, which is 2. See? That's what I am creating right here. And then what I need to do is just go my incrementer and increment it. And that is going to be the way that whiles are normally created. It's going to have the incrementer defined outside, and then of course the incrementer is going to have to change in some way so that at some point in time this condition no longer is true, and the while loop then ends. And I'll show you another example of the while loop here in a moment. And you can see here how many bits, and if we say 3 for example, top value is going to be equal to 7. And how many bits did we say an integer can actually hold? Well, 32. However, remember we had that problem where some are positive and some are negative. So what we're actually going to have to do in that situation is go 31 and get an approximation of the biggest number that an integer could possibly have. Otherwise, if we come in here and run this and type in 32, what are we going to get? -1. Why? Because it jumped back to the beginning of the negative numbers and the integers. So don't worry about that. Just more information, just playing around. Because that's what I like to do when I'm writing code. I like to play around as much as possible to keep things interesting. So now let's do another thing with our while loop, so I can give you an example of how to use a break statement. So let's say we want the user to come in here, and we want them to keep guessing what our secret number is between 0 and 10 until they get it. How would we do that? Well, we're going to have number guessed is equal to 0. And then what we're going to do is create an infinite loop like that. This isn't the only time you would use a break statement. This is just one time in which you would use a break statement, which is basically whenever you want to avoid a potential for an infinite loop, or you want to automatically always throw yourself out of a while loop if a certain thing ever happens. You're almost always going to use a break statement with an if statement, so as you're going to see here. So I'm going to say guess my secret number, like this, number guessed. Then what we're going to say is if number guessed is equal to the secret number, this guy up here, well, in that situation, what we're going to want to do is print f, you got it. But then we don't want to ask them to enter another one because they guessed it. So what's something we can do? Well, if we want to break out of the while loop and jump down here to this point down here after the while loop is over, we type in break. And break will end the loop. And you can see if we run it, here we are. If I type in 4, it asks me again. 6, asks me again. 2, it asks me again. And then the magical 10, and it ends. And it types out, you got it, right like that. That's kind of cool. And that's another example of a while loop. Another thing that is very useful in programming, no matter what anybody says to you, is a do while loop. Now you're going to use a do while loop whenever you need something done at the very minimum one time. But you don't know how many times you're going to need to loop thereafter. And that is also the difference between the do while and the while loop and the for loop, which you're going to see here in a second. So you might ask yourself, well, when would I ever need to do something once every single time? Well, let's say we want to ask for the size of a shirt that somebody wants to buy. This is a good example of that. Well, the while loop is going to come down here after the do, and this is when the condition is checked the very first time. We're going to say size of shirt not equal to letter S, and then we're going to do this a couple other different times. This is going to be the condition that has to be met. Size of shirt M, which for medium, and size for shirt is L. Then after that, to finish off the while loop, we're going to put a parentheses and a semicolon. Make sure you don't forget that. Well, what this allows us to do then is we know we're going to have to ask for the size of the shirt once. So we'll say what size of shirt. And then after that, we're going to say that our option is S, small, medium, large. Those are the only options available. And if they don't enter that, well, the while loop's going to ask them again until they get it right. And let's make sure that we put size of shirt and not size of course. File save. So they ask what size of shirt. Let's say you type in K, doesn't work. Let's say you type in M, doesn't work. Lowercase m anyway. And you type in uppercase M, and then it works. So there's an example of how do while loop can be very, very useful. And that brings us to the for loop. Now you're going to want to use a for loop when you know up front exactly how many times you need to loop through something. And the basic format of a for loop is you're going to type in for, and you are going to define an incrementer. And I'm actually going to use the C99 version of the for loop in this tutorial. And then you're going to define a condition and another semicolon, and then you are going to increment your incrementer, and then put a whole bunch of things between curly brackets, and that's how for is defined. So let's say you wanted to define something that is going to count to 20. How are you going to do that with for loop? Well, I'm going to go int, and I'm going to say counter. Now, you're not going to be able to do this in anything other than C99 or above, as you're going to see, and we're going to have to change our little way of compiling over here to take advantage of that. Otherwise, you'd have to actually initialize this outside of the for loop, but I prefer to do it this way, just to understand those differences. Okay, so we got our counter. Then we're going to say as long as our counter is less than or equal to 20, what we want to do is we want to continue incrementing our counter, like that. There we go, tab. And then we're going to print out our counter, like that. Now remember, I said we have to compile this in a different way. What we're going to do this time is go GCC, then we're going to type in std, not the bad type, C99, C tutorial, 2.c, dash lowercase o, and then we're going to put our C tutorial 2 inside of there as well, just like we did previously. Cut that, paste it over here, and you see, whoops, what's it say? Warning, return type defaults to int. What they're referring to is main. Inside of the 99 version of C, main must have a return type, unless you type in void. Void means that there is no return type, so you don't need to worry about that. But by default in C99, you need to return an integer, unless you say, hey, I don't have anything to return, don't push me around. There you go. You can type in void. And that's what that does for you. So now if we save it again, come in here, bounce it in like that, execute it, you can see that it counts out 0 the whole way to 20. And that's an example of our for loop. And that's going to give me the opportunity to show you how continue works. Let's say you decide you only want to print odd numbers. Well, how can you do that? Well, there's this nice little thing called continue, and I'm actually going to chuck this up to 40. And what continue is going to allow you to do is skip the current iteration of the loop and instead continue with the next loop cycle, which is going to increment counter in this situation. And how we're going to be able to use it, again, if is very often used with an if statement. We're going to say if our counter modulus 2, which means whenever it's divided by 2, it's going to return to me a 0 for the remainder. Well, that means that it's even if we type that in there. And what we want to do is continue. And what continue means again is to skip this and jump up here and increment the counter again. And if we save that, bounce over here, and execute it, you're going to say that it only prints out odd numbers. So there is a whole bunch of different things you can do with the C programming language. Please leave your questions and comments below. Otherwise, till next time.